Hello, everybody.
Hello.
We'll wait a couple of minutes so more people can join. Welcome to the webinar. I hope all of you are in a nice and cold place. I know it's really hot in France, at least. And yeah, I believe we can start.
Yeah. Let's see. Okay, we can start maybe. So, hi everyone, and thank you for joining us today for this webinar. So this webinar is will be a new shorter format. So we will be showing you mainly the new main features that are available in the last cognitive design release, which is the 2.1 release. So I am Gregorio Carasi. I am the product manager, and I'm here today with our CTO.
Yeah. Hi, everybody. I'm Henri de Charnacé, CTO and co-founder of Cognitive Design Systems. Some of you might also have seen us in the last webinar. So for those who don't know us well, so we are Cognitive Design Systems software company. So just a quick introduction. We are based in Toulouse, and so our software assesses challenge on concept design mainly. So it allows the engineers to explore really fast a wide panel of designs and to identify which concept design would be the more cost-effective or more performant. And once you have found the methodology to make your concept, you can reuse the workflow. So you will see right after during the demo, you can make some workflows and reuse them in order to apply the same methodology to new designs. And so we also assess all the problematics of AI adoption. For those interested, we also have some R&D previews of a version of the software that works with LLM agents.
Okay, so let's look at the new feature in Cognitive Design 2.1. So for this release, we worked mainly on two topics. Let's say the first one is simulation. So we added thermal and thermomechanical analysis capabilities, and we added a new boundary condition, which is flexible remote load. And we also worked on generative design topic, where we added a new objective in the topology optimization, which is the stress objective. And we did some enhancement in our manufacturing and design for machining. So let's start from the simulation capabilities. So as I said, we added on top of structural simulation capabilities, we also added thermal and thermomechanical simulation. So it works exactly the same as the structural simulation. And we also added new KPIs, which comes from this new thermal analysis, which is mainly the max temperature that comes from the thermal field. So with this you will be able to do design exploration, not only on looking at structural performance, but you will also be able to do thermal analysis and exploration on with thermal analysis. And the second new thing is the new boundary condition, which is the the remote load. So until now, you only had the possibility to set up loads, vector loads directly on surfaces. But now you can also apply those vector loads on a remote point, which is then connected to a set of surfaces. So even if we are in early concept stage and early design exploration stage, we are well aware that results without physically accurate simulation are not meaningful. So we are working on also with our partner Intact Solution. We are working on giving you as much standard, let's say, boundary condition as possible. So match as much as possible what you could have in ANSYS, for example. And of course, give you fast simulation. So let's see how this looks like inside cognitive design. So let's start from the thermal and thermomechanical simulation. So here in this example, we will look at a piston head, for example. So as you would do with a normal mechanical setup, you set up your the component on which you want to do the simulation. So now in your custom material, you have mechanical property, but also thermal properties you can set up. So here you have the surface selection where you want to apply your boundary conditions. So for example, I have several sets of rings and grooves on which I will apply my boundary conditions. So for the mechanical setup, I think if you already used the software, you have several types of restraints, mainly fixed displacement or sliding restraints. And then you have different surface loads you can apply. So in this case, I applied some pressure loads. And for the new thermal setup, it's exactly the same. So you have surface conditions. You can choose between convection, fixed temperature, or thermal flux. And you also have, if you want, internal conditions, so mainly constant heat. If, for example, you want to you have your body generates heat and you want to simulate that. So in addition to the mechanical load case, you have now the thermal load case that you build exactly in the same way of the mechanical load case. So you input basically your surface condition, boundary condition, and internal boundary condition. And now in the solution block where you set up all your solver settings, you have the choice between mechanical simulation, thermal simulation, or thermomechanical simulation. So in this example, thermomechanical simulation, you have both the mechanical scenario and the thermal scenario. So since here I have done a thermomechanical simulation, I will have both the results of the mechanical simulation, so displacement, for example, von Mises stress. So those are the results you already have with the classical and the mechanical, the structural simulation. And then in addition to that, you have now the temperature field and the heat flux results. So as I was saying earlier, you can now use these results also in the design exploration. So you can take your reporting block. So you plug your simulation result and your component, which is here. And you can save your results to the design explorer. And you have access now to, for example, the max temperature result. So you can explore also on looking at temperature. So a little new feature we also added to enhance, let's say, the visibility of your workflow is that now you can click on any block and you can see clearly in which blockchain is situated. So you can see which blocks are connected with your with the block you selected. So it's easier to navigate and also to quickly check if you missed some inputs. Another little thing we added, I'll just show you quickly, is that now when you do computes, you will have a notification system. So you can do different several compute, they will be in a queue, and you will be notified when each compute is finished. And also the errors, if you have errors, you will be notified. So it's easier to see where there are things to change. And you can also see how much the duration of the compute, and when when was your latest compute. So it's we already have the recompute feature if you have something you need to recompute, but with this latest compute, you can also clearly see if you need to recompute something. For the flexible remote load, so here nothing really difficult, just in the surface load block, you will have now access to remote force. And you have also the possibility to do remote force plus a moment. And so in your remote force, you just input the remote point, and the direction of the vector, and the magnitude of the load. So now let's go back to the presentation, and let's look at the generative design updates. So first of all, we added a new optimization objective. So you already have the compliance objective, and now you have the stress objective. So you can do either compliance only or stress only, or a combination of both. And we improved our manufacturing and design feature for machining. So now you will have much more control over the shape. So you can choose whether you want something more or less prismatic, or you can also have the control on the pockets you open inside the geometry. So on the depth of the pockets. So I will show you in cognitive design. So first of all, stress objective. So for a topology optimization, the setup is exactly the same simulation. And then here you have the let's say the compliance only topology optimization setup. So you for those of you that already use the software, you probably already use this this block. You can set up the volume fraction, the iteration, and all the optimizer parameters. And so after 30 iteration, you have something like this. And now you can use the stress objective topology optimization. So it's the same setup, just you can tune the weight of the stress objective. So here, for example, I put weight 1, so it's stress objective only. So for complex part, and often it's better to do a combination of both objectives to have a better results and better convergence. So usually you can use a stress weight like 0.9, something like that. So after 30 iteration, you have this result, which is optimized for stress. But let's see the actual simulation results of those two optimizations. So I put the same volume fraction on both 0.3. So if you look at the result of the compliance optimization, you have a weight of 380 grams, max displacement 0.07, and 67.5 megapascal of von Mises stress. And if you look at the stress objective, you have the same weight, roughly 380, because you have the same volume fraction. The displacement is a little bit higher, 0.9, because you are optimizing mainly for stress. And your stress is lower at 53.5 megapascal. So as you can see, you have to do a trade-off. You have to try different parameter and different weights to obtain what you want, because if you do compliance objective only, we will have less displacement but higher von Mises stress. And if you do only stress objective, you have, for example, 21% reduction of max von Mises stress, but 29% increase of max displacement. So it's you have to tune this based on what you want to achieve. So since we know that doing this kind of trade-off is not always easy, we are also working on introducing constraints. So stress constraint and natural frequency constraint. So here it will be easier. You will just need to specify what is your max von Mises stress and optimize for this with this constraint. So this will be it's something that will be available in the next releases. So just to come back here quickly, this topology optimization with stress objective is at the moment a beta feature. So in case you don't see beta blocks, you just have to go into settings and enable the show beta features. Okay, now let's look at the last new, let's say, last upgrade of this release. So let's go back a little bit. What is manufacturing-driven design? So you can look at manufacturing-driven design as a continuation of generative design, part of the generative design process, and it's the it's the feature that gives you the possibility to really create shapes that are compatible with the desired production process you have selected. So instead of, for example, doing a fully constrained topology optimization with manufacturing constraints, you can do a normal topology optimization, or in this case, run a topology weaving, obtain a result that is often complex and not it's usually more compatible with AM processes, but you want to make it compatible, for example, in this case for machining. So you can use the manufacturing-driven design for machining, for example. And here I simplified the shape in all three directions, X, Y, and Z. Depending on your shape and on your geometry, sometimes it's better to simplify the part only on one or two direction. But in this case, I did it on three directions. So you can see you have something that is more prismatic and more compatible with a machining process. So what's changed from the last, let's say, version of MDD machining? So in the previous version of MDD machining, you had results that were a lot more prismatic, but also added a lot more weight. So we kept this in the new MDD. It's just these flattened outer surfaces. With these flattened outer surfaces, we will have more prismatic results that are more suitable, for example, for 3-axis machining. And here, if you don't use this, you have still something compatible for machining, a little bit more less prismatic with less volume, which is better for example, a 5-axis process. So you have a better control on the final shape, how much prismatic you want the shape. And the other thing you have the control now on is the pockets. So here I choose, for example, to recreate pockets from the topology optimization or weaving result. So you can say that I reopened some pockets and I can tune the depth of the pockets and also the area of the pockets I want to reopen. So obviously you can also decide to not reopen the pockets, so you have a fully closed machinable part. And you can tune the depth of the pockets. So if you want pockets that go through like the original result, you can also tune the parameter to obtain this result. So the objective of MDD is to give you a shape that is as much close as possible at what you might expect for some kind of manufacturing process. But you obviously you still want to modify some details on it, because the part is not always the final part. So you can when you are satisfied with your result, you can always generate a CAD file, a step file from your geometry, which will have clean functional region and also flat surfaces. And you can go on modify this result in CAD. Okay, so now let's look also. I will show you. I will also show you what's next. So just a small spoiler of what's coming soon. And actually, the 2.2 will come very soon because we plan to release this new version next week. So you will be able to use it already next week. And what will be new in this release is the new license system. So we will be available to we will be we will be able to provide floating licenses. We also changed the how macro blocks behave and can be generated, so it will be much easier to create groups, to create macro blocks, and to share also those blocks. And also we made it easier to work on the project optimization with passive regions. But we will talk in detail about this, and I will show you everything on the next webinar dedicated to this release. Okay, so thank you very much, and yeah, we can now answer to some question. I think Henri already.
Yeah. Thank you, Gregorio. Yeah, so we had a question about heat exchanger optimization. So to add a bit more details on this,
Yeah.
so currently the topology optimization is for mechanical cases, but you can also create heat exchanger geometries directly with the functions of cognitive designs. So there are several ways you can go about this. We can use lattices, for example, to create two fluid heat exchangers. There are also some options to connect zones together. So for example, if you have a set of surfaces, we can create an envelope around all of these surfaces, which is pretty interesting. For example, if you want to reduce the mass of a manifold to print it in 3D. And regarding the simulation, so we support importing the results, any results. You can just bring them as a CSV file with XYZ and, for example, your velocity values. And we can use these results to modify the geometry. So for example, if you have some low velocity zones, we can remove them using field-driven operations in order to optimize further your shape and only keep the zones that have a nice flow, for example. And just a last detail on this, so we recently partnered with a company called VoxShell that will allow you to easily export and mesh, especially, your part and to use it in Fluent, for example, or other CFD tools. So it's mainly meshing software, and it supports implicit. So you can have really complex heat exchanger shapes with lattices, for example, and create pretty easily a nice mesh for simulation, including the boundary layers, for example, also the boundary conditions. So it will really ease the loop to optimize parts for CFD.
Yeah, and I think this answers actually both questions, because we are not now planning to have a fluid software inside cognitive design, but with this partnership, we are making it easier to export geometry to do fluid simulation on other with other solvers, basically.
Yeah, so I hope this replies to both of your questions.
Yeah. Yeah, so I think
okay, so we have another question. So about the remote force vector, can we automatically set it to the normal, to the selected CAD surface? So right now, there is no such option. So you have to put your, you have to put yourself the direction as a vector. However, if you use a pressure, for example, you can have a normal force to any point on a surface. it's interesting feedback. And new question from Alexi: is the workflow automated within CDS, prepare geometry, mesh, send to solver, get results? So I believe it's for the CFD export. So regarding the Voxshell partnership that we have. So right now, it's not yet integrated. You just have like Voxshell running next to Cognitive Design. You import your part to it and you mesh the geometry. But in the midterm, we plan to integrate this directly inside Cognitive Design, so you can directly export your setup file as a .inp, for example, to directly use it in Fluent or other CFD softwares.
Okay. So I think that's it for today. And if you have other questions, you can always contact us. And yeah, so thank you very much. Yeah, I will see you on the next webinar.
Thank you, everybody. Have a great day.